A point is chosen at random within the square in the coordinate plane whose vertices are 0, 0, 2020, 0, 2020, 2020, and 0, 2020. The probability that the point is within d units of a lattice point is 1/2. A point xy is a lattice point if x and y are both integers. What is d to the nearest tenth? There are 5 options A, B, C, D, E. So, to solve this problem, we have to firstly draw a graph. So let's just say that this is our 2020 by 2020 square. Now what does the problem say? The probability that the point is within d units of a lattice point, so in any integer point, is 1/2. So we want to analyze it microscale first. So let's just zoom in on this random lattice point. So let's say that this is a 1 by 1 square. And, well, so this is part of the grid, okay? So this is part of the grid. And let's say that this is the lattice point we're zooming in on. So we want to know the area of the points that are d units within this lattice point. Well, that's just a circle with radius d, because all the points within the circle are d units within the lattice point. So that's just a circle. And the same thing for all the other 4 lattice points that we can see. So there's just 4 circles on this graph if we zoom in. And if we look at the specific square over here, the square, so if we zoom even more in, this is just the square of, well, a square that contains 4 quarter circles. So this is a 1 by 1 square, and it has 4 quarter circles, and the radius is d for distance. Right? So what's the area of the circle? Because there are 4 quarter circles, there's just 1 circle. Now what's the area of the circle? That's just pi d squared, because d is right now the radius. So a 1 by 1 square has pi d squared area. That is a circle that should contain all the points that are d units within the lattice point. And if we expand onto this, so if this is a 2000 by 2000 square, then we have like a lot more 1 by 1 squares, but all the 1 by 1 squares are the same thing as this one. So we just consider this as the probability. So basically, we know that the probability is 1/2. So if we plot if we choose a point in the square, like by random, so for example this point, there's a 1/2 chance that this random point will be within one of the quarter circles, meaning that this pi d squared thing is 1/2 the total area. What's the total area of the square? It's just 1, so that this is just 1/2. So this tells us that d squared is 1 over 2 pi. And d is just 1 over root 2 pi. Now what is pi? Pi is 3.14. So this is 1 over root 6.28. What's root 6.28? We know that root 4 is 2 and root 3 is 9. So root 9 is 3. So this is somewhere between 2 and 3. So let's see. Let's try 2.5. We know that 2.5 squared is 6.25 because 25 squared is 625. So this is 6.25, so pretty close. So we can just say that we can approximate that 6.28. The square root of 6.28 is 2.5. So what's 1 over 2.5 then? 1 over 2.5 is 1 over 25 over 10. So this is 10 over 25. So what is 10 over 25? If we multiply the numerator and denominator by 4, that's just 40 over 100, which is around 0.4. So you can just round this to 0.4, which is b. So thanks for watching.